So, what is glycolysis? Well, glycolysis is the way of life. It's part of cellular respiration that occurs in all living things. Glycolysis follows under an aerobic respiration, which is a process that extracts energy from food. But although it usually requires oxygen, but in the case of glycolysis, it doesn't necessarily need it. So, what are the reactants involved with glycolysis? ATPs are converted into ADPs as soon as the phosphate group is given away. It repeats this cycle for one pyruvate molecule. It also produces 10 enzymes and also NADH, which converts into NADHs. So how will I present glycolysis? I'll use the game of musical chairs to show the 10 steps that glycolysis revolves around. To represent the steps of glycolysis and the reactants, I'll be using carbon to represent the people, the phosphate group to represent a new member into the group, a hydrogen molecule to represent the removal of a chair, and other elements will be represented by spectators. ATPs will represent when the new member is going to be added. The first step to glycolysis begins with one glucose molecule. There's 6 carbon molecules, which represent 6 players, and also other elements, which is the oxygen molecules and also the hydrogen molecules. In order for the glucose to go on to the second step, it must use an enzyme called hexokinase. An ATP is made and formed into an ADP due to the loss of a phosphate group onto the next molecule called the glucose 6-phosphate. The musical chairs game begins with 6 players. They were just finished discussing about the rules and how they're going to play it. But just before they decided their group members, they decided to add another member. The second step to glycolysis is the transformation of glucose 6-phosphate to fructose 6-phosphate by using the enzyme called phosphoglucomutase. The players and the new member begin to play their first round. In order for the second step to precede the third, it must add an ATP to create an ADP. When another ATP is added onto the third step, there's 2 phosphate groups. The enzyme that is needed in order for the ATPs to work is phosphofructokinase. The molecule is now called fructose 1,6-biophosphate. While trying to play their first round, another member wants to be added into the group. Now there's 2 new members and 6 original members. In total, there's 8 people. In the fourth step to glycolysis, the fructose 1,6-biophosphate is split into 2 molecules. One is called glyceraldehyde 3-phosphate, and another one is dehydroxyacetone. In order for this separation to occur, it needs aldolase, which is an enzyme. Once again, their round of musical chairs gets interrupted due to a huge dispute that happens between the 2 additional group members. They decided to go on to their separate ways, creating 2 different groups. After its separation, the DHAP molecule must be converted to a G3P, which means that there's a total of 2 molecules per molecule of glucose. Since there's a conversion factor, in this game of musical chairs, I'll be focusing only on one of the groups. On the 5th step, it shows a G3P molecule. After the dispute, the new group members decide to gather around to talk about the first round. The G3P molecule goes under an NAD reaction, which takes an hydrogen out of the molecule, which the NAD becomes an NADH. From there, another phosphate group is added. After playing their first round, a chair has been taken. Just before then, another group member wants to join onto the group. Step to glycolysis. A second round is played and the new member leaves due to the loss of the chairs. It takes forms of an ATP. That means that the ADP gained a phosphate group. creating an ATP. On the 8th step of glycolysis, on the 9th step of glycolysis, a water molecule exits. After an intensive round, 3 spectators leave in the form of elements. On the last step of glycolysis, an ADP comes in and takes form of an ATP. That takes the last phosphate group that is in the molecule, creating 2 pyruvate molecules. In the final round, the last member loses and leaves the game.